Hello, welcome back. We are on chapter 6, rational expressions, and we will work today on section 6.3, simplifying complex fractions. The first objective will be to simplify complex fractions by simplifying the numerator and denominator and then dividing. A few definitions here. Complex rational expressions are rational expressions whose numerator, denominator, or both contain one or more rational expressions. There are two methods that can be used when simplifying these complex fractions. The method number one is to simplify the numerator and the denominator of the complex fraction so that each is a single fraction. The next step is to perform the indicated division by multiplying the numerator of the complex fraction by the reciprocal of the denominator and simplify if possible. Let's check an example and understand how to proceed it. So we have a fraction that's composed by other fractions. That means a complex fraction. We have a fraction here on the numerator and another one on the denominator. Check the first step. First step here is to simplify and make each one as a single fraction. We have a fraction and a number. Let's make it a single fraction. And then we're gonna make this like something like that. Both the numerator with the same denominator and the denominator here. And let's see, here is going to be x, right? And here 2 times 2, 4. And on the other side, we're going to have x here, and 2 times negative 2, negative 4. We will rewrite this as multiplication. Remember last section we learned how to multiply, how to divide the rational expressions, transforming it into multiplication. So if we have division, this x plus 4 over 2 divided by x minus 4 over 2, we can rewrite as x plus 4 over 2 times the reciprocal of this denominator, which is 2 over x minus 4. Simplify 2 with 2, and we're going to have as a solution x plus 4 over x minus 4. Sorry, minus 4. This is the simplification of that complex fraction, complex rational expression that is the original expression. We use the first method now, and the next objective here is to simplify complex fractions using method number 2. Let's see how to do this. To simplify a complex fraction using method number 2, the first step is to multiply the numerator and the denominator of the complex fraction by the least common denominator of the fraction in both the numerator and the denominator. Applying to an example, and check this example here. Let me write here on top. We have the following denominators. We have y squared, we have 3, right? We have y, and we have 6. And let's find the least common denominator. To find the least common denominator, if you remember, we're gonna identify the unique terms. So we have y is a unique term, and we have y exponent 1 and y squared. Actually, going to use the greatest exponent, y squared. times, and we have here 3 and 3 times 2. So 3 is another unique factor and 2 is another unique factor. The least common denominator as a result is 6y squared. Excellent. We found the least common denominator. We're gonna multiply on the top of this complex rational expression and on the bottom of this complex rational expression, the numerator and denominator. So multiplying, let's write like this. Multiply this by 6y squared and the bottom by 6y squared. Let's check the results. 6y squared. Let's write everything so you can visualize, you can understand. And then after we rewrite, we simplify. 6y squared times 2 over 3 over 6y squared times 1 over y. Here is times 1, right? And minus 6y squared times 5 over 6. Now let's simplify. Y squared here, we can simplify with this, y squared. 6. We can simplify with 3, and then the remainder is 2. Y square, we can remove this square here, we can simplify actually with this square, this y, and 6 we can simplify with that 6. Rewriting, then we have 6 times 1 plus 6 times 2, y squared times 2 times 2, 4y squared, over 6y times 1, 6y, minus y squared times 5, 5y squared. And think, when you have something like that, you just think a little bit if you can simplify even further, a little bit more. And I cannot find anything that I can factor out that might help simplifying even more this rational expression. Therefore, this is the final result. This is the simplification of this original rational expression. Simplification now. Let's check another example. Let's simplify x plus 1 over y divided by over, again, x over y plus 2. And let's use this second method. First you identify the denominators. All the denominators have y, and 1. So the least common denominator here is going to be, obviously, is going to be y, right? Multiplying y on the top, on the numerator, and on the denominator, then we're gonna have, here we simplify x plus 1, and on the bottom we simplify just here x times y. Let's write everything so you understand. X times y over y plus 2y, and we are simplifying just this one, right? Y over y equals 1. We can simplify, and then we can rewrite this as x plus 1 over x plus 2y. So this is the simplest rational expression resulting from the simplification of this complex rational expression here. Next objective, simplify expressions with negative exponents. And let's understand this. When you have a rational expression where some of the variables have negative exponents, rewrite the expression using positive exponents. The resulting expression is a complex fraction, so use either method, the method that we have seen before, to simplify the expression. One example, and we have here, this is, check it out, we have negative exponents, right? Negative exponents on the numerator and on the denominator. And we can rewrite, remember, if you have x exponent negative 2 is the same thing, is equal to x 1 over x exponent 2. We can rewrite like that. So this is going to be 1 over x exponent 2 times 1 over y exponent 2 over, and here 5 is not submitted to the exponent, so 5 times 1 over x plus, and 2 is not submitted to the exponents, 2 times 1 over y. And we can use method 1 or method 2. That's up to you. You can choose either method. You can choose one that you feel more comfortable, you feel that you can more easily understand and more easily apply. I will use the second method. We're gonna find the least common denominator, and it's kind of easy here because you have x squared times y squared on the top, and we have x and we have y. So the least common denominator is going to be x is a unique factor to the greatest exponent times y is another unique factor to the greatest exponent squared. Multiplying, but let's multiply on the top by x squared times y squared, and on the bottom by the same, x squared times y squared. Will result, let's see here, let's write, let's do step by step. So I'm gonna rewrite everything here, x squared times y squared times 1 over x squared times, and actually you can put all this together. See, this is equal to 1 over x squared times y squared, right? This whole numerator. So let's put this together. Let's write something like that, and here is going to be x squared times y squared. Okay, and fixing this is not straight. Let's draw a straight line, kind of straight, and here 5 times x squared y squared over x plus 2 times x squared y squared over y. Check if you got everything right. Just make sure if you understand this step. This thing here, this is equal to 1 over x squared times y squared, right? It's separated here, but you can put it all together like this. It's the multiplication of two rational expressions. You multiply the numerators and you multiply the denominators, and you get this. Just make sure that you understand this step. Okay, moving on. Let's go down here and let's simplify all the things that we can simplify and make it much simpler and nicer rational expression or fraction. And we simplified here x squared with another x squared here, y squared with this y squared here, and this x squared we can simplify with that x, and this y, and this is actually y squared. Sorry, this y squared, right? We can simplify with this y. Then we will have, and here on the top the only thing left is 1, and on the bottom we're gonna have 5xy squared plus 2x squared y. Always think just a little bit to see if you can simplify more, if there are anything else that you can factor out and simplify from this last rational expression resulting of your work. And if there's nothing else that you can factor out to be able to simplify, then that's the final answer. That's the end of section 6.3. Thank you for watching.